So to begin with the simulation, I will be modeling the load which is getting supply from the 110 baud 33 kV transformer. So to model the simple network, I have to model the transformer over here and I have to connect the load in this network. To get the supply, I need to include the grid also here at the 110 kV. So here you can see there is the bus bars and terminal in which I have to select the bus bar and I have to include it for modeling 110 kV and 33 kV bus bar here. So here it's already 110 kV and at here I'm changing the bus voltages to 33 kV and I'm connecting the two winding transformer between 11 kV and 33 kV buses and I'm defining the transformer type over here. So at here you can see there will be two options available. One is to select the transformer type and another one is to create the new project type. So when you have some existing transformer model available in your network, you can select the transformer model from here. In case if you want to create the new transformer model or new transformer type, you can click this new project type and you can see the new window popping up like this, and at here you have to enter the rated power of the transformer. In our case I'm entering the transformer parameters at 25 MVA and I'm changing the nominal frequency at 60 Hz and I'm changing the rated HV voltage at 110 kV and LV voltage as 33 kV, and I have to define my vector group over here where I have to change my vector group as DYN and I have to update my phase shift as 11. So over here I can be able to define my transformer impedance and X by R ratio, and I can also directly enter the parameters like copper loss or resistance and reactance in per unit by switching its input mode, and at here I'm keeping my short circuit voltage as 6% and my X by R as 20, and for zero sequence also it's 6% and XPR ratio of 20. With this I'm finishing my transformer modeling, and next thing is with the grid. So in the grid I have to change my bus type to slack bus. Yes, in case if you are leaving the bus type as PV, Dixalign Power Factory automatically it will takes the PV bus as the slack bus for the simulation. And coming to the load, I'm connecting the load at the 33 kV and I'm setting my active power as 10 megawatt. So at here I can directly enter the active and reactive power over here, and I can also change my input mode from active power reactive power to active power with power factor. So for this I have switched my input mode to active power with power factor and I'm changing my power factor to 0.8. With this I'm done with the modeling, and if we need we can rename the bus names grid bus, and with this the modeling is done, and the next step is to perform the load flow analysis for this simple network. So to perform the load flow analysis you can directly enable the load flow option by clicking this icon, or you can go into the calculation toolbar and you can select the load flow from here, and yes, you can perform the load flow analysis directly using this. So at here you can see that there are quite a lot of options available with active power regulation and reactive power regulation and temperature dependency and the load options. So we can see all these options on the later stage of the course. For now we can use the default settings available in the Power Factory and we can perform the load flow analysis. So yes, the simulation was completed and you can see the results in the network. So this is the bus voltages in per unit and the rated kV. So to enable the units, you can click this toolbar and you can right click and you can go to the edit format for nodes, in which you can enable the units for the bus terminals, and the same will be reflected on the single line diagram over here. So at here you can be able to see that my 33 kV it's getting reduced to 32.3 kV, and the per unit voltage it's 0.98 per unit. So to see the branch flows and to enter the inputs, you can again go back here and you can enable the units, and yes, you can also increase the decimal units, and if needed you can also include few more variables in the simulation. So if I want to see the total apparent power, this can be viewed directly from here. So here you can be able to see that the active power which I'm getting from grid it's 10 megawatt, and the reactive power, the loss of reactive power which is in the range of 0.4 MVA. So if I'm increasing the precision, even I can see more accurate values. So here you can see that the loss it's in the range of 0.38 MVA. So if I want to get the total summary of this network, I can directly go into the output toolbar and I can select the load flow, in which I can get the total grid summary from here. So for this I have to maximize my output window and I can see the overall summary from here. So here you can be able to see that from grid it was generating 10.02 megawatt and the load it's 10 megawatt. So the grid loss is totally it's 0.02 megawatt. And in the reactive power you can see that the total generation is 7.89 MVA, and the load which is observing 7.5 MVA, and the loss which is at 0.39 MVA. So yes, this grid summary it will gives you the overall summary of your network, and you can be able to get the overall idea about the components that you are using in your projects.